We're using ancient technologies to design and build most of our buildings. The mainstream engineering materials like steel and concrete, really the way we use them hasn't changed in probably 100 years. And I think that with a little bit of cunning, we can fundamentally change the amount of material we use, the amount of energy we consume in making those materials, and actually get a much better fit between the performance of a contemporary piece of architecture or a piece of engineering and the materials and resources that go into it. Steelwork up there would have been familiar to somebody in Chicago in 1880. We're still using it in 2011. And it really hasn't changed. If you think what's happened to cars and planes, computers in the last 100 years, and then think what's happened to the building industry, you think we might be lagging behind a bit. It's been designed to be easy to make. So it's like squeezing toothpaste. It's exactly the same wherever you slice a steel beam, top, bottom, middle. Doesn't change. And the basic problem with having a beam which is the same all the way along is that the natural forces that act on it are not the same all the way along. And so the perfect beam would be one which is shallow at the end and deep in the middle. We've recently been talking to a very large international company who are keen to develop this technology. And they have a prototype, they have a patent pending to make a rolling mill which can roll the perfect beam. Now, if that comes off, and if it becomes in common use around the world, we're going to save 120 billion car miles worth of energy every single year. You'd hope that as we move through time, we would get better at designing. But if you compare Olympic Stadia, for example, Sydney, if you just look at the amount of energy that was required to make the steelwork in the Sydney Olympic Stadium, it's equivalent to the energy you need to drive about 80 million miles. Still quite a lot of energy. If you move forward to the Bird's Nest in Beijing 8 years later, that has got enough energy to drive 725 million miles. So it's nearly 10 times as much energy as there was in Sydney 8 years earlier, which to me is not a great sign of progress, no matter what other virtues the Bird's Nest may have. I mean, if you look at smaller stadia, like the Water Cube at Beijing, it has enough energy in that steel structure to drive 43 million miles. And that's for only a capacity of about 6,000 people. The velodrome that we've just designed for the 2012 Olympics only needs enough energy to drive 7 million miles. So it's 6 times more efficient for the same size venue as the well-celebrated Water Cube. To me, I think that shows that you can design something that does the job, something rather beautiful, still being mindful of the environment, still being mindful of the resources. You don't need to be quite so gratuitously extravagant with materials as, I mean, the worst example I do think is the Bird's Nest, which should have been knocked off its perch. I started thinking about what could we do about it. And it became obvious that there's no point in going for the Old Glory project because so few people get the chance to work in that. So what we're trying to do is to aim right for the middle ground. So houses, offices, factories, where there are lots and lots of engineers working, lots of architects working, loads and loads of materials being used, and really try and get a sort of a scale multiplier on a piece of thinking that is long overdue, in my view. Of course, a lot of buildings are not brand new, done by modern computer techniques. They're actually old buildings that we've had around for 50 years or 100 years, and they've still got a pretty good life ahead of them if only we look after them and if we can adapt them. So there are many examples of very successful transformational designs where architects and engineers have taken existing buildings and have given them a completely new lease of life. And we did one at Baker Street, at the old Marks and Spencer's headquarters. We went into Baker Street with our client and said, we think we can keep the building. And by doing that, we managed to save 35,000 tons of concrete, and we saved the energy equivalent of 22 million car miles just for that one building. Now, if every building that's in London at the moment could be regenerated and reused for something else, then that cuts down the amount of energy that we have to use to redevelop London big time. So it's lunchtime, that's why there's no one in the office. But here's a rectangular concrete column. Up there is a rectangular beam. It's the same all the way along. And then straight above our heads is a completely flat concrete slab. So most of that is useless. I mean, most of that is just excess baggage. As an engineer, you have to resist every natural phenomenon acting on a building. And some of that is written down in the legislation. And it hasn't changed much over the last 100 years. So this is the London Building Act from 1930. And in here it talks about the sort of loading you have to use for offices and for houses. So it says, for an office or a counting house, you have to take a load of £100 per square foot of floor area. Now that's equivalent to something like 5 or 6 big blokes standing on every square metre of an entire floor of office, which is just ridiculous. Now, we still are asked to design our buildings for that level, that intensity of loading, which is simply nuts. If I start looking at the loading in here, this is the same sort of space that some letting agents and the rules and regulations suggest should be designed for something like 300 or 400 kilograms a square metre. So, you know, I can pick up these things. There's a table. That doesn't weigh 300 or 400 kilograms. That covers a couple of square metres. So this is basically a fairly conventional office. I mean, in desks, computers, not many books. Nowadays, these offices are empty. There's nothing in them. We might as well design for Queen Victoria. That's what we're doing. And she's been dead 100 years. If you come down here, around the corner, so this is where now we discover what everybody does at lunchtime. In that little space there are about 25 or 30 people, and the intensity of loading there is roughly 40 kilograms a square metre. And that's about a tenth of the figure that is described by most commercial office clients. You know, and that, I mean, I challenge you to get more people into a space than there are sitting there. I mean, they're absolutely jammed in as tight as you can possibly get them. So where is all this load coming from? And by over-designing and over-specifying every single office building, every single domestic building, we're just throwing material off into the ether. It's completely pointless, just wasting it. Enough is enough is the culmination of 20 years of frustration. I've been working in this industry using what I think are technologies that are just miles and miles out of date. And you look around at all the other industries around the place and you think, surely the building world, the architectural world, the engineering world can move a bit faster with the times. That must be enough, isn't it?